today we're jumping into our third version of factoring, and arguably the most common and most important kind, and this is going to be factoring trinomials. So it's still kind of rooted in FOIL. It's still the opposite of polynomial multiplication. Just the numbers and signs that you'll see here are less specific than they were for difference of perfect squares. So on this one we have double positives, we also have a 3 and a 5, so not the same number and not opposite signs. So the process for FOIL is still the same. Just to recap how this works, we'll get x squared when we do x times x. X times 5 will make 5x. 3 times x will make 3x. And 3 times 5 will make 15. Now pay attention to these numbers and how they're interacting whenever we get to our final answer. So our final answer is, after I combine those like terms, we'll have x squared plus 8x plus 15. So think back for a second with that 5 and the 3 and how they kind of interacted to make the numbers that you see in your final answer. So we used them first here with 3 times 5 to get 15. And we actually used the same two numbers added to get that middle term whenever we combine like terms. So 3 plus 5 made 8. So it's this relationship that is at kind of the heart of factoring trinomials. Now today, the more familiar you are with your multiplication tables, the easier it will be. However, you can use a calculator to support that and to help you make the list of factors that we're going to need to make it happen. Now these equations are going to take a little bit different format. They're going to look like x squared plus bx plus c. Now they don't have to have plus signs. They could have minus in either position as well. But b and c are just going to be numbers, so you won't see those variables filled in there. Now, what we have to do on the numbers that we're trying to find are going to have to multiply to be c. So they have to multiply to be that last number. Okay, so think based on the FOIL process that we have. And they're also going to have to add to get b. Now, sometimes you can think of this as subtraction here too, if you need to, and you'll see that in action. I'll show you kind of what that looks like if you're struggling with the signs, which, that's our next note, is to be careful whenever we start mixing positives and negatives. Choosing the right signs is important to make sure that your answer is accurate. Now, we can still get prime polynomials. And again, you would see a GCF of 1, which actually happens fairly often on these. You typically have a GCF of 1, but they can throw in other GCFs as well, and that's why we check for that first. But the other thing that you would see for a prime polynomial on this option is that there's no pair of numbers that can meet both of the criteria. You might find all kinds of numbers that multiply to be c and all kinds of numbers that can add to be b, but none that are the same and that would match. All right, so if we think about our general steps, first thing we want to do is check for a GCF. I'll give you a little preview here. None of these top ones here have a GCF. This one down here doesn't have a GCF either. It's only these last two. So I will probably talk about checking for a GCF on the first one, but then just not worry about it again until we get down here. Okay, that's just how I designed the notes. So what we do first after checking for a GCF is list all the things that we know to multiply to be c. Sometimes it's a short list, sometimes it's a long list, and that's where your multiplication tables come into play. Now, if you're feeling comfortable enough with your multiplication tables to not write that list down, that's okay too. You'll get more comfortable as we go. Now, thinking about all the numbers on your list, we have to figure out what pair will be b. Now, typically, we're trying to add. That's actually what goes on that line right there. And then we're trying to make b. Now, again, that could mean subtract whenever we get to some other problems with combo, addition, and subtraction. And then we're going to take the two numbers that meet both of those criteria to make our final answer. We are still going to get two binomials. And the order, the numbers doesn't really matter, but the signs on those numbers do matter. So we'll check that out in this first problem. So if I look through, I don't have a GCF for numbers. I have 1, 12, and 32, so only one will work. And I also don't have a GCF for variables either. We have x squared, x, and then no x at all. So I know that I'm ready to move into this new factoring method. So what I start with is that last number, so 32. And I'm going to list all the things that can multiply to be 32. And I start with the easiest one, 1 and 32. And then I usually work my way up from there. If I divide by 2, does it work? Yeah, on this one it's 16. Divide by 3. Oh, 3 would give me a decimal, so I don't include that on the list. 4 would get matched with 8. And I could keep trying numbers until I run back into numbers that I already have on the list, but 4 and 8 should be the last pair. So I've narrowed down my pairs of numbers as options pretty significantly. Now I want to try to add these pairs to see if I can make it equal that middle number. So I'm trying to take factors of 32 and add them to get 12. It does have to be members of the same pair, so I couldn't add, say, 1 and 8. Not that that makes 12, but we can try it out that way. Okay, so I have 1 plus 32 is too big, it would make 33. 2 plus 16 would make 18, also too big. But here's the winner, 4 plus 8 also makes 12. Okay, so I'm gonna use 4 and 8 as part of my answer. So I'm gonna create 2 binomials. X still goes in the front, it's just I'm taking this x squared and splitting it apart. So here's one x and there's the other. All right, and then out of what we chose a positive 4 and we chose a positive 8. So that dictates where the signs are. So I could have this written as x plus 8 and x plus 4, and that would mean the same thing. It would be the same answer. Okay, if you're looking to check, you can always FOIL this back through and see if you get back to your final answer. You can do it real quick. Here's x squared, 4x plus 8x would make 12x, and 8 times 4 makes 32. So it does check out. Some problems are really nice because they have nice short lists, like 10 would just have 1 and 10 and 2 and 5. And out of that list, I'd be looking for the pair that adds up to be 7 here in the middle. So out of that list, 1 plus 10 is no good, but 2 and 5 should work. So 2 and 5 are the numbers that are going to make up my answer. So again, I'll throw n's here in the front, and we picked a positive 2 and a positive 5. So again, 2 times 5 makes 10, and 2 plus 5 makes 7. All right, one last one with double positives. Double positives are by far the easiest because you don't have to worry about signs so much. But we'll do one more here. This one does have one little extra thing to talk about on it for you. So we have 1 and 16, 2 and 8, and 4 and 4 is options here. The pair that's going to add to be 8 should be 4 and 4. It's not always the last one, I promise. All right, so we got x plus 4 and x plus 4. Both of those were positive. Now notice that because both of these two things are the same, I'm taking something times itself. So we can rewrite that if we're trying to be fancy with a squared. You'll see that occasionally in Algebra 1, but pretty often in Algebra 2. So either of these is a correct answer. All right, we got another one here. I'm going to look at 15. I'm going to make a list for 15. All right, so 1 and 15 and 3 and 5. And that should do it for us. Now I'm trying to find the pair that adds up to be 7. If I add this first pair, I get 16. And if I add this second pair, I actually get 8. So it looks like I don't have a pair that meets the criteria. So what I want to do at this point is I want to think, again, just double check. Is there anything else that can multiply to be 15 that's not a decimal? And there isn't. And since I don't have a pair that meets those criteria, this one is actually prime. Again, prime doesn't come up super often, but it can, just so you know. Most of the time, people want to see you actually factor, or tests want to see you actually factor, so they don't usually make prime very often. All right, so let's start moving into ones with subtraction in it, in those minus signs. So this is where we have to pay attention to our signs. So I do have a positive 35 out here on the end that I'm going to make my list for. It's a surprisingly short list. I always feel like this one should be longer, but it's just 1 and 35 and 5 and 7. So I have to think here. I can tell 5 and 7 are related to 12. 5 plus 7 makes positive 12, but I need a negative 12. So I have to think about how I can still multiply to get a positive number, but add to be a negative number. And it's a pretty easy switch. If I can find the pair that gets me the positive version of this number, then I can just switch the signs and make them both negative. Because remember, negative times negative will still make positive, but negative plus negative will make negative here in the middle. So it only changes my binomials just a little bit. Okay, we still put the x's in the front, but now we have a negative 5 and a negative 7. So it changes my binomials to having 2 subtraction symbols. All right, a similar thing's going to happen here. If I have that plus sign here, but a minus sign here, I'm going to need 2 negatives. 24 has a surprisingly long list. I think it's why it's my favorite number. All right, we have 1 and 24, 2 and 12, 3 and 8, 4 and 6. All right, so I need the pair that ends up multiplying to be 24, which all these do, and then adds to be negative 11. So if I'm looking at these, I can get positive 11 by using 3 and 8. So that means if I make both those negative, I should be able to maintain the positive multiplication, but get a negative for subtraction. Okay, so we're going to change it up even a little bit more. Now the number here in the back is negative, which if you're trying to multiply to get a negative, we are going to need one of each. We're going to need a positive number and a negative number. So this makes our lists actually double in size. So think about things that multiply to be negative 18. I can do negative 1 and 18, but that could also be switched, and I could say that it's negative 18 and 1. I usually like to organize mine with all the negatives on one side and all the positives on the other. That way I can make sure that I've hit it both directions. So we have negative 2 and 9, and also negative 9 and 2, negative 3 and 6, and also negative 6 and 3. And I think that will do it for 18. So now I need the pair that's going to add up to be a positive 7. So I can tell 6 and 3 are too close together. 9 and 2 seem like a good fit, and I have to be very careful which pair I choose. I want the one that has positive 9 and negative 2, because that'll leave me with a positive 7. Negative 2 plus 9 is positive 7. This is where you can also kind of think subtraction. You can think of it as 9 minus 2 makes positive 7 as well. So when I make my answers, it just means I'm going to end up with something negative and something positive here. So again, it is okay to switch the order. So I could have a plus 9 and a minus 2. That's fine. What I can't use is this pair. I couldn't have a minus 9 and a plus 2. It would make this sign here incorrect. All right, similar deal on this one. Okay, this is the other option, is thinking of it as straight subtraction. So if this seems like too long of a list, if you can work with the numbers kind of in your head, you can. That's cool too. But here's what I can also think of this as. I can think of it as 1 and 16, 2 and 8, or 4 and 4. And then I can think about combining these numbers in some way with addition or subtraction to create negative 6, which means I'm going to need subtraction somewhere. So if I think, let's see here, I think 2 minus 8 will equal negative 6. So that tells me what pair I actually need. I used a positive 2, or I started with a positive 2, and then I subtracted 8. So it allows you to kind of figure out the signs using subtraction instead. All right, here on the next one, the other weird thing is if you don't see a number here in the middle, that number is 1. I'm going to go ahead and start with my list for negative 20. So I got negative 1 and 20, negative 20 and 1, negative 2 and 10, negative 10 and 2, and I think the other one is negative 4 and 5, and negative 5 and 4. All right, so this just shows me all the options for adding and subtracting those positive and negative numbers there. It looks like the ones that I need are going to be the negative 5 and the positive 4. Now again, if you're feeling pretty comfortable enough to not write down these lists, if it's jumping out at you which pair that you're going to need, that's awesome. And you can go ahead and skip writing down that list. So the last one here is negative 9. I'm going to go ahead and show you the subtraction way one more time. So this would just be making your list like normal. Not much to choose from here. And I'm trying to make a positive 8 using the pairs of numbers that I have. So I know that if I take this pair here and treat it like 9 minus 1, I can get positive 8. So it shows me that I'm going to end up using a positive 9 and a negative 1. All right, before we get into the more complicated questions, it's a great time to pause the video and try out these two. Okay, so if you're ready to check your answer, this one, the pair that you needed is a positive 6 and a positive 5. And that's because 6 times 5 makes 30 and 6 plus 5 makes 11. All right, on the other one, we do have some subtraction there. The pair that you needed is x minus 8 and x plus 3. And again, if you have x plus 3, x minus 8, you're in great shape as well. Okay, here are ways that they could make this a little bit more complicated for you. They can throw in extra variables. Doesn't happen often, but can. So just take a look. What we want to do is ignore the fact that the y is there. So I'm really just going to treat this like x squared plus 6x plus 8. And I'm still going to make a list for positive 8 here. So 1 and 8 and 2 and 4. Nice short list. So I'm trying to find two things that add up to be 6, which would be 2 and 4. So similar to the ones that we did like this on difference of squares, I'm going to leave myself some extra space in the back. And pick a positive 2 and a positive 4. And just throwing a y at the very back actually takes care of the whole thing. Now you might be saying like, okay, well, what about the xy there? It's all taken care of. Think about FOIL. X times x makes x squared. This would be 4xy plus 2xy, which makes 6xy, and 2y and 4y make 8y squared. So just by putting the y's there in the back, it takes care of the whole thing. All right, now our last two do take care of all of our steps. You are going to see some GCFs on this problem. In this section, you can tell because of the number in the front. In the next factoring lesson, we won't be able to get rid of those numbers in the front, which changes the whole game, makes it a lot more complicated. You can also tell if you have some wonky exponents, it could tell you that you might need to have a GCF in there. Okay, so if I look at the first one, a GCF between 2, 20, and 50 is actually going to be 2. So if you think back to our GCF lesson, we have to divide that out. So it'll look like x squared plus 10x plus 25. So now I should be able to keep going by making my list for now 25 instead of 50. So 1 and 25 and 5 and 5. So the pair that adds to be 10 is 5 and 5. So the 2 still stays as a factor in your problem. It is part of your answer. And then I have 2x plus 5s here. Similar to that really fancy one that we did in our first row of examples, you could, if you're feeling fancy, you can go ahead and write it like that as well. So either this or this is a great final answer. The last example here does include a variable as part of your GCF as well. So between 3, 24, and 144, 3 is going to be your GCF number-wise, and then x cubed, x squared, and x will be your GCF. After that, we're going to divide that out. That'll give me x squared plus 8x minus 48. So we do have to worry about the signs here as well. 48 has kind of a long list. So I'm going to do it the subtraction way just to save myself a little writing. So I know I have 1 and 48, 2 and 24, 3 and 16, which is one I commonly forget about, 4 and 12, and I think 6 and 8. And out of that pair, the pair that can get this 8 right here, remember, we're not working towards 24 anymore. We're working towards this that we've taken the GCF out of. I can get 8 by doing, let's see here, it looks like 12 minus 4 will give me positive 8, like I'm looking for. So the 3x stays as part of your final answer. And we're going to need a positive 12 and a negative 4.